Hi, good evening. You can hear me, right? आवाज साफ आ रही है? Just figuring out the audio. Okay, audio is good. एक second. The camera is misbehaving a little bit. I'm going to fix it right away. So today we're going to talk about well, haloalkanes, the second part of haloalkanes, right? Today, 1 second. And here we go. You should see me right about now. All right. So हम लोग बात करने वाले हैं आज preparation of haloalkanes. We did preparation of alcohol. Now we look at different kinds of preparation from other sources. I don't know. We'll try and make a single substituted haloalkane, double substituted. Yeah, we'll do that. From alkanes, from alkenes. Then we look at how to make aryl haloarenes. Haloarenes भी हम लोग देखेंगे, ठीक है? तो quickly, let's look at NCERT के हिसाब से क्या क्या करने वाले हैं, and then we'll get started. Optimus Maximus, it's been a minute. How are you doing? All right, just 1 second. Let me open up NCERT as usual. And here we go. This is what we're going to be doing today. Hold on. ये सब हम लोग कर चुके हैं. This is already done. Done. In yesterday's class. कल था क्या? परसों था class. Oh yeah, yesterday was my day off. Feel like a Sunday, but it wasn't. It was a Wednesday. Hold on. Yeah, we've done this. यहाँ तक किया था. This is where we're going to look at, right? From hydrocarbons, simple ways, ineffective but simple. Ineffective because you don't know which one you're going to get. You can get multi-substituted compounds. We'll look at that as well. Alkene से कैसे होता है? There's an interesting there's an interesting reaction mechanism if you use instead of HX halo acid, if you use something like this, क्या होता है? We'll see. हम लोग देखेंगे. Yeah, halogen exchange reaction. We'll do all of this today. We will do till Sandmeyer reaction. Victor Mayer is different. Sandmeyer. All right. So till here, I think physical properties होगा कल के session में, परसों के session में. ठीक है. So looks like it's just a couple of pages, but 2 pages, 2.5 to 3 pages. But we'll do a lot of practice when it comes to actual NEET/JEE questions. Okay. मतलब कि बताओ कितने products form होंगे. They'll give you some very innocent looking reaction. Let's say how many products are going to get formed? Like, wait, what? How many products? So some use of stereoisomerism हम लोग उसको यहाँ use करेंगे. ठीक है. चलो. Just to give you a hint as to what we're going to do today. Shall we get started? Let's get started. Yeah. नहीं आवाज आ रही है? You hear me, see me, right? You have a question. You want to post on the server. Put it on the server, Optimus. Better put it on the server, no? I mean, I can't go off track and put it on the server. Hey, Rajanya, how are you doing? Hey, Rachana. Same to you. Go to the iTeach Camp Bento link. Go to the Discord server. Go to Telegram server. Ask whatever questions you want. I'm not going to take questions that are outside of what we're talking about today. What are we talking about today? We are talking about. Wait, hold on. Ta-da-da-da. This preparation of alkyl halides from all of these. Okay, in तीनों चीज हम लोग देख रहे हैं. Halogen exchange, hydrocarbons, alcohols. Alcohol is done. We are doing these other two things today. All right. So to make hydrocarbons from alkanes and alkenes, the easiest one is that you take a regular alkane, you add a little bit of a gas to it. Which gas? Chlorine, bromine, iodine, fluorine? Not fluorine. I'll tell you why. We'll see. So you add just the gas directly, and you'll notice that on my screen it says free radical mechanism. What on earth is free radical mechanism? We'll talk about it. When you do this, it's not very useful because you get a mixture of stuff. And usually, when you're trying to produce something chemically, you want a very specific reaction. You go through a lot of trouble to produce one specific thing. And this is saying you get a mixture of things. So it's not very useful. But it's the first thing that's in NCERT, so we will study it. And this is the most easiest way to do it. Okay. So UV light, and chlorine. What does this do? What does UV light do? It breaks chlorine homolytically. This is not a division sign. These are two electrons that make up this bond. Okay? And it breaks very nicely right in the middle. Okay? That's what this free radical means. Homolytic cleavage. Homolytic cleavage के बारे में आप लोग 11th standard में पढ़ चुके हैं. Okay? Now, what is the other kind of cleavage that can happen? Heterolytic cleavage. Other kind that can happen. Doesn't happen here. What could happen is maybe this. And maybe say not here. Okay. But the other kind, under some other conditions, this could happen. ठीक है? We'll talk about that too. थोड़ी देर में बात करेंगे. कैसी conditions क्यों, etc. Anyway, so the kind of mixture of products you get. Now I've taken butane. Butane साथ मैंने chlorine डाल दिया, free radical mechanism because it forms this thing, right? This right here. All right. What does it do then? Okay. This C H. If you got a free radical close to it, this guy also breaks homolytically. Let me write it down like this. Okay. And say one of these guys just becomes this C dot and H dot. Of course, there are other hydrogens here. There's a etc. और चीजें यहाँ पे लगी हुई हैं. This then goes and attacks this. That's it. And you're done. Reaction खत्म, product बन गया. But it doesn't, well, it doesn't just form this product. It also forms this product. And in fact, this is the major product. Why? Why is this a major product? It's totally free radical mechanism. Well, we'll talk about that as well when we do SM1, SM2 reaction and all of that. क्यों ये major product है, etc. We'll do that. Also, this works for chlorine, bromine, not fluorine because that's explosive. Okay, it is. That's not where it works. Okay. Yeah, I think iodine also. Sure, let's put iodine also here, but not fluorine for sure. Just taking this. Yeah. And also, a tertiary radical is more stable than secondary, more stable than primary. These are things maybe you have heard of in GOC and hydrocarbons in 11th grade. Have you heard of this about free radicals? कुछ पढ़ा है, नहीं पढ़ा है? Vaishnavi Ravuri. I'm going to be speaking in English, right? English and Hindi mixed. That's the goal of this channel right now. Considering it is related to today's topic, Optimus, अगर था related तो अभी तक तुम पूछ लिया होते. If I'm talking about a question and it's related to a question, go ahead and ask it. Or just put it on the server. In the time and effort you're taking to put that comment, just put the question on the server till now. Okay. So the rate of reaction now. Okay. Same free radical halogenation thing, right? We're just talking more about this. So the rate of halogenation, this is the most. And I told you this is explosive. So we don't use this, right? We don't use this. We don't use this to form fluoroalkane. We don't do that. These kind of, okay. Reactive hydrogen, tertiary, secondary, primary. What are we talking about? We're talking about free radicals. We're not talking about दूसरी कैलोरीज होती है कार्बोकैटायन. No, we're not talking about that. We're talking about free radicals. Okay, this is important. This is not a hydrocarbon. It's a free radical. Free radical मतलब कि बस एक bond था, homolytically टूट गया. If you do heterolytic cleavage, then you get a cation and an anion. We are doing homolytic cleavage. These words are fine, right? ये शब्दों में कुछ मुश्किल नहीं लग रहा है, right? Homolytic, heterolytic. Please let me know. That's important. Let's take a quick question right away, right off the bat. सीधा एक सवाल लेते हैं. A gaseous hydrocarbon X on reaction with bromine in light forms a mixture of two monobromoalkanes and HBr. What is the hydrocarbon X? ये बढ़िया सवाल है. देखो, it's almost like math now. You've got some products and you've got to kind of back calculate and get, what was the original thing that reacted if you get just two monobromoalkanes? Okay. Can you try this out? Okay, Rajanya. Hey, Joel. Hey, Mehak. How are you doing? Vaishnavi, are you able to follow what I'm saying, or like, is this too much English, too much Hindi? I don't know. I don't think I'm talking too much Hindi, but anyway. Rachna, are you trying this question out as well? Okay, let's analyze यहाँ हो क्या रहा है. You get two monobromoalkanes. How will you get two monobromoalkanes? Now, अगर मैं यहाँ पे bromine लगाऊं या यहाँ पे लगाऊं, it's the same compound. If I say this is 1 and this is 2, they're the same compound. So this is, you eliminate this, okay? If I add bromine here, or here, or here, I've already got 3 different compounds. 1, 2, 3. These are 3 different compounds. You know, नाम से बता सकते ना. Bromo, कितने हैं? 1, 2, 3, 4, 5. Bromopentane, then 2 bromopentane, then 3 bromopentane. You already got 3. This is not true. Okay. What about this guy here? Oh, this is going to have a lot of. This is going to get complicated very soon. 1, 2, this, and the interesting thing is, if I add this here, this is chiral, और अगर यहाँ पे लगाएं तब ये chiral नहीं होगा, but this guy here is chiral for, no, hold on, let me think about that. If I add this bromine here, then both of these are the same. Okay, so you get a lot of, it's more than 2 for sure. I've shown you 1, 2, 3, 4, 5. I've shown you 5, and there's one more because this is chiral, so it forms enantiomers, etc. There are 2 of them. Okay, complicated, not the answer. Then must be this. So how are there 2 here? A here and 1 here. Oh, easy, peasy. And there's no enantiomer, there's no chirality, so we are good. I think it should be C. Rajana thinks D. D में तो बहुत ढेर सारे बन रहे Rajanya. I'm getting a lot of alkanes. Yeah, I don't think it's B. I feel it's C because if I make, say, this compound. By the way, अगर आपको ये line diagram में मुश्किल हो रही है, please get used to this. This is easier to deal with as compared to big carbon chains and all of that. अगर question में carbon chain बना भी है, then try and get it to this. Trust me, it's easier to follow. Maybe initially if you start doing things, it may be like, oh my god, what is the line? What is this? What is that? But other डाल लो, trust me, it's immensely easy, especially if you are trying to look at chirality or enantiomers and all of that. Optically active compounds, geometrically active compounds, etc. Line diagram is significantly easier. Wedge dash diagrams, etc. Most good books use these kind of diagrams. Okay, anyway, so these are the two bromoalkenes. This is just what, if you want to name it, this is bromopropane. Well, you can call it one bromopropane, but ठीक है. This is two bromopropane, right? So yeah, these are two things. That's it, and hence this should be the answer. Easy question. Okay, shall we go on? It's okay. Don't worry about it. Joel, Mehak, and Optimus, are you trying this? Are you trying this question out? Please help us with this. Help yourself. This will get you. This will help. This will make you get better at whatever exam you're going to be giving. Yeah, whether it's JEE Main, NEET, IIT, next कोई भी exam में ये आपको help करेगा. ये वाला भी मजेदार है. Number of possible enantiomeric pairs that can be produced during monochlorination of 2-methylbutane. So we're going to do monochlorination again. Monochlorination of 2-methylbutane. अब पूछ रहे हैं enantiomeric pairs. How will you get an enantiomeric pair? पहली बात है कि there must be some chiral atom. Chirality का मतलब है ना, you know what chirality means? Chirality means कि there will be some optical activity. Why will there be optical activity? If the 4 things that carbon is bound to, they are different. Hence, it will be optically active. अगर ये चीज आपने रिवाइज नहीं की है, please check out my stereoisomerism lectures जो हैं bento links में. You can check that out. I'm guessing you've already done this in 11th grade, but if you haven't, please go through this. Okay, I'm going to go ahead and explain this, assuming you know what stereoisomerism is. Okay, पहले इसको ड्रॉ करते हैं. What is 2-methylbutane? 4 हो गए. This is butane. 1, 2, 3, 4. 2-methyl is this. 2-methyl है क्या? हाँ, तो 2-methyl is just this. Okay, great. Now, where is the, what should I call it? Where can we add chlorine so that you get enantiomers, so that you get chiral compounds, right? Let me put that here. You need a chiral molecule, and this is 2-methylbutane. Okay, so if I add, say, chlorine here, is that chiral? No, it's not, because यहाँ पे 2 hydrogen है. This is not chiral. Okay, cool. So everything I draw in yellow is going to be not chiral. Okay, and if something is chiral, I'll change it. I'll make it green or something. ठीक है? That's the, let's go with that scheme, so to speak. Monochloronated. Okay, ठीक है, ये एक बन गया. Just for the sake of clarity, I'll sit and redraw these things ताकि आपको confusion ना हो. यहाँ पे chlorine डाला, तो is that chiral? Of course not. Well, actually, this one could be chiral. That's interesting. ये वाला तो chiral लग रहा है मुझे. Not this right here. You'll have a Cl here, right? Okay. When I do this, this becomes chiral because it has 4 different groups over here. ठीक है? ये हो गया methyl. ये हो गया ethyl. So this becomes chiral now. Oh, great. Let's change this up. There's no more yellow. It should be green. Hey, look at that. Accidentally, we found one chiral molecule. Awesome. ठीक है, एक मिल गया. और बाकी क्या करें? अब मैंने यहाँ पे क्लोरीन लगाया. अगर मैं दूसरी जगह लगाऊं तब भी सेम ही होगा. अगर मैं यहाँ पे लगाऊं, और if I say do this, that's the same compound. Okay, it's not different. It's the same compound. Okay, great. So we got one enantiomer pair. एक मिल गया अभी तक. अब क्या करें? Next में क्या करें? Let's do another one. I'm going to go back to my awesome yellow marker. Okay, great. If I put chlorine here, is that enantiomeric? It looks pretty enantiomeric to me. ये है isopropyl group, right? ये है methyl group. यहाँ है hydrogen. तो ये भी हो गया chiral, है ना? This is chiral as well. These are the only 2 things that I see that are chiral. If I make this here, this is achiral. And just to keep sense of, just to keep it color coordinated, ये है achiral. ठीक है? Cool, because there are 2 hydrogen groups here which are the same group. Does it make sense? So I found 2 enantiomeric pairs, right? 2 chiral carbons that can get formed if you do mono substitution. They're different compounds, no doubt whatever. They're same compound नहीं है obviously. एक में हम लोग क्लोरीन यहाँ ऐड कर रहे हैं, ठीक है? On the first carbon itself, and then the second one we're adding it to the second carbon, the other side. ठीक है? Cool. So I feel that the answer should be 2. What do you think? Mehak and Rajan, you think it's D as well? All right, awesome, great. Optimus भाई कहाँ गया? Yeah, it's 2. It's 2, it's 2, it's 2. Excellent work, everybody. Another one, another one. For the given reaction, how many products are optically active? Now we want all isomers. All isomers? Same ही चीज है. Same question again, but with a different compound. How is it the same question? Optically active are going to be those that have chiral centers, right? And the only kind of activity, you don't have geometrical isomerism, it's just optical here. No double bonds, nothing. Okay, great. So let's, the first thing जो मैंने आपको बताया था, मैं चाहता हूँ कि हम लोग उसको line diagram में convert करें. So this is a tertiary methyl thingy going for it, right? So let's do that. This is the tertiary methyl group, okay? Then you've got this another carbon right here, then another one here, एक और methyl और ये. Let's count that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Number मैं ऐसे ही कर रहा हूँ. I'm not saying this is the number, but just checking. 1, 2, 3, 4, and 5. Okay, great. And you've got the actual numbering could be different. I'm not saying when you try name the compound ऐसा number करना पड़ेगा. I'm just seeing if the diagram I've drawn is correct or not. The line diagram. बस ये देख रहे हैं. ठीक है. Now I'm going to erase those numbers, and this is the representation of this compound in the line diagram kind of way. ठीक है? Cool. Okay, that's step number 1. What is the next step? Next step is हम लोग को add करना है bromine. I'm going to assume monobrominated products just to make life simple. Because अगर मैं 2 bromine add भी करूं, no, let's not talk about that. Let's just do monobrominated for now. ठीक है? Let's talk about monobrominated products. Okay, great. So there is no hydrogen here, nothing here, right? So यहाँ तो add होने का chance है ही नहीं. It cannot add there. Now it can add here or here or here. It's the same thing, right? This तीनों same है. ठीक है? If I attach it here, this is the right way to write it. ठीक है? Line diagram में एक चीज जरूरी है. Don't reduce the number of carbon atoms. ठीक है? अगर if I write like this means there's a carbon over here. Okay. So you extend that line and add a Br. Don't add Br there itself. That means a carbon कम होगा. So be careful about this. Line diagrams are great and awesome, but figure out how to use them. ये जरूरी है. ठीक है? Okay. So this is one compound I found. Is this इतनी कहानी के बाद? Is this optically active? Not really, right? No. There are 2 hydrogens here. There's 1 hydrogen here. Same group. And यहाँ पे भी same group. ठीक है? So this is not optically active. Okay. Okay. अब क्या करें? ये वाला तो नहीं हुआ. Where can I add? Where can I add if it to make it optically active? Let me reproduce this diagram एक दो बार. Line diagram. ठीक है? Of this. Okay. What if I add bromine over here? Bromine add करना था. क्या करना था? Bromine add करना था. यहाँ add कर दिया bromine. Okay. If I add it here, see, oh, that's interesting. See, then this becomes chiral. So I'm going to use my green color thingy again. ये chiral हो गया. यहाँ पे है bromomethane, so to speak. Bromomethyl group. This is methyl group. And there's some other big group, whatever. कुछ और. So 3 different things and you have hydrogen. We got one. We got one. Right? 3. Rajana says 3. Okay, let's see. How 3? Yes, Joel, nice. Rajanya, how 3? Can you tell me? मुझे लग रहा है, and this is just my gut feeling, that if you have X chiral centers, you get 2 into X to be the number of optically active isomers. And again, when I say 3 optical centers, I mean 3 अलग-अलग compound में. अगर same compound में 3 optical centers हुए, तब तो, I mean, तब chiral centers, then you got to do part 3, that's fine. If we get 3 different optical centers, chiral centers in 3 different compounds, it will be 2 into 3, 6. So do you mean 3 or do you mean 6 or do you mean some other number? मुझे लग रहा है it should be an even number, Arjun, is all I'm trying to say. I like what Joel is saying. Let's see how we get to the second one. Mehak says 4. Okay. On third C in chain, okay. Third C. When you count 3, आप किस तरफ से ठीक है देखते हैं. किस तरफ से 3 count करोगे? Let us see. Let us try. Okay, 1, 2, 3. Oh, interesting. So Rajan is saying, यहाँ पे लगा दो bromine. I like that. Do I? Yes, I do. Okay, great. This looks like it's chiral as well because this is an isopropyl group. What is this? And this is a tertiary methyl, whatever, carbocation. Tertiary butyl, sorry. 1, 2, 3, 4. No. 1, 2, 3. 1, 2, 3. Yeah. Not tertiary. It's a tertiary carbon. Let's just call it that. Not tertiary butyl. It's not that because it's just got. Oh, it is actually. This is tertiary butyl. है ना? 1, 2, 3, 4. हाँ. This is a tertiary butyl group. Okay, sweet. And you've added a bromine over here, and यहाँ पे एक और hydrogen छोटा सा यहाँ पे लगा देते हैं. और छोटा सा hydrogen. ज़्यादा छोटा हो गया. Space constraints. Okay, great. Yeah, I found two. That's about it, I think. और कहीं पे भी मैं लगाऊंगा, it's going to be the same, right? If I add methyl bromine यहाँ पे, इधर, here or here, it's going to be the same. Same, okay. So I can get, if by adding bromine here, I make this the chiral center, or by adding bromine over here, I make this the chiral center, right? Those are my only two options. Anywhere else I add bromine, यहाँ पे तो कर नहीं सकते क्योंकि चार बॉन्ड ऑलरेडी से लगे हुए हैं. We are not considering rearrangement or any sort of this part because it doesn't make sense to rearrange यहाँ पे कोई rearrangement possible नहीं लग रहा है. Also because it's a free radical mechanism. ठीक है? So if the rearrangement was too much, ignore it. But there's no rearrangement happening here. ठीक है? So these are the two chiral centers that I found. Hence the answer should be 2 into 2, which is 4. We good? Yeah. Joel, thank you for that. Lovely. I think Joel figured it out the fastest. Rajanya, you good? It should be 4. Mehak, ठीक है? 4 होना चाहिए. Yeah. Vaishnav, are you still here? Optimus? Fun question, right? All right. So let's go ahead and make hydrocarbons from alkenes. You didn't think कि इतनी simple cheese, which is from alkenes, you'd have so many awesome questions on it. But that's the goal. That's what we're doing. Right? We're preparing for JEE and NEET and IIT and all the exams. Possible. Okay. The theory is chill, okay? It's the kind of questions that are going to be asked. That is what gets interesting in organic, especially this part of organic. Okay. So I can make alkene से दो तरीके से. Alkene में मैं monohaloalkane बना सकता हूँ या dihaloalkane बना सकता हूँ. ठीक है? The next method. We finish regular, just straight chained alkanes. Now we're going to alkenes, adding something to alkenes to get haloalkanes. Okay. Monohaloalkanes, let's add HX, hydrohalic acid. Now what is X? What is X? X में हम लोग, I'll tell you what you can use, what you can't use. You can't use iodine. Okay, you can't use iodine because HI is a very strong reducing agent. It's a strong acid, also a strong reducing agent. So it will reduce everything and not good. We'll talk about that. So what do? We will make it in situ. मतलब अगर we do want to use HI to produce this, but we can't just add HI directly. You will produce it in situ. Okay, I'll talk about what is that. मैंने last time परसों के सेशन में बताया था कि what is the meaning of in situ, right? You make two things react ताकि वो ions present as solution. But you don't add HI directly because that will mess things up. Okay, anyway, HBr की बात करते हैं. This is easier to look at. This is a symmetric alkene. Symmetric मतलब कि डबल बॉन्ड के दोनों तरफ सेम चीज लगी हुई है. ओके, ठीक है. तो यहाँ पे मैंने ऐड किया तो एक तरफ हाइड्रोजन एक तरफ ब्रोमीन लग जाएगा, खत्म. दिस सिंपल. व्हाट इफ यू हैव एन asymmetrical alkene like this? Asymmetrical मतलब जो डबल बॉन्ड की एक तरफ देखो देयर इज एन इथाइल ग्रुप, दूसरी तरफ है मिथाइल ग्रुप. नॉट रियली मिथाइल बट ठीक है. देयर इज अ डबल बॉन्ड, राइट? there are two carbons on one side, one carbon on the other side of the double bond. ठीक है? HBr add करो and then you get two different products. The one जहाँ पे edge में बिल्कुल end में जाके bromine add हो रहा है, that's a minor product, and right in the center the major product. Why is that? This is called the Markov-Nikov rule. V is pronounced as F in German, and also that's Markov-Nikov, right? That's what it's called. You can call it Markov-Nikov, you can call it whatever you want. You can just write MKV. But basically, the more substituted carbon, वहां पे जाता है bromine. क्यों? क्योंकि now you get carbocations, and carbocations जो ज्यादा stable है, वहीं पे जाके bromine attack करेगा. Now in this case, it's very clear. And see, this is the most beautiful thing about organic chemistry. Every organic chemistry reaction is an acid-base reaction. तो यहाँ पे तो actually acid add कर रहे हो. बाकी तो आपको थोड़ा ढूंढना पड़ता है acid क्या base क्या है. It's very clear. This basically, as soon as you put it in water, you get H plus and Br minus. Now, because of this awesome sort of a thing, ये Br minus है क्या? This is a Lewis base. It has, well, negative, it has electrons, it has negative extra ions and all that. So what is a Lewis acid? Something that has a plus charge on it, right? A carbon that is positive. How do you get a carbon that's positive? We'll see very quickly. देखो, this is your, this is the asymmetrical alkene we're talking about. Yeah, here is your acid. It comes here. Now this H, it attacks this guy. Rather, carbon wants this guy, and this goes there, the other side. Now, why does that happen? Because this plus charge on this is stable. Okay. The secondary carbocation is a lot more stable than the primary carbocation. These are things you have पढ़ चुके हैं 11th grade में, GOC में, hydrocarbons में. If you don't remember that, thermodynamically stable है, ठीक है? Which means you give it enough time. Time मैंने दे दिया, time का चक्कर नहीं है. There are two things in organic chemistry, anywhere else. If you don't have time, you let things happen very quickly, or that's kinetically limited, और आराम से करो, बहुत टाइम है, एनर्जी ट्रम्प्स. तो यहाँ पे भी हम लोग चार्ज की बात करते हैं, स्टेबिलिटी ऑफ प्लस चार्ज माइनस चार्ज, देन यू आर टॉकिंग अबाउट थर्मोडायनामिकली स्टेबल प्रोडक्ट्स. ओके, ग्रेट. सो देयर टू अटैक साइट्स प्रैक्टिकली, या, एंड सेकेंडरी कार्बन हम लोग जो है ज्यादा स्टेबल होता है, as opposed to this is where you get primary carbon being formed, primary carbocation being formed. Let's see, I think so this must be it. Yeah, hold on, let the animation run its course. HCl, all right, Chandu. Chandu, I don't know what you're talking about. Unless there's an official something from the NCRT, sorry, from NEET, then I will not know. Man, Chandu, I missed the awesome animation where it was showing the primary cation being formed. Hold on, I'm going to look at it once again, and then we'll talk about whatever you're talking about. I haven't seen this, dude. If there's somebody spreading rumors, ignore it. अगर NTA से कुछ ऑफिशियल आता है तब देखेंगे, ठीक है. हाँ देखो, इसमें H जा रहा है कार्बन के पास, मतलब यहाँ बन गया ये, so this is less stable. Primary कार्बो cation less stable, ठीक है. But you cannot prevent products being formed. So दोनों form होंगे, but this is going to be a major product and this is going to be a minor product, ठीक है. दोनों बन जाएंगे. If you want to make only this, you have to put a little bit more effort. What that kind of effort is, we'll learn subsequent classes. Okay, that was one way. That was a way to figure out how to make monoalkanes. And yeah, ये चीज मैंने आपको अभी explicitly नहीं बोली, but I'll say it again. I did kind of mention it in situ banana. We don't add HI because this is a reducing agent. So then what do? We want H plus and I minus ions in solutions. What do? Well, we can form them in situ. मतलब NaI और H3PO4 को react करेंगे या फिर KI को, ठीक है. ये मैंने आपको लास्ट सेशन में बताया था. Why H3PO4? Why not H2SO4? Because same thing. They're a strong acid. They will mess things up, right? They will form HI. So, नहीं, that's not good. And those are oxidizing acids. H3PO4 is like, ठीक है, chill. एक H plus देगा, दूसरा देने के chances कम है. H2SO4 if you put, it is going to give both those H plus ions. Please, it's important that you look at the whole picture. ठीक है, reaction conditions are extremely important in organic chemistry. You got an idea about reaction conditions जब आप equilibrium में पढ़ रहे थे, equilibrium में आप लोग catalyst डाल रहे थे and all of that. So all of that is going to come back here. Okay, catalyst and ये क्यों डाले, ये क्यों डाले. So make sure you know क्यों reaction conditions हैं जैसे हम लोग डाल रहे हैं. This is why you say that to produce say Ri with this method you use this, okay, and not Hi. HBr is good. HCl is good. Fluorine हम लोग बाद में देखेंगे. Okay, dihaloalkanes कैसे बनाया जाए? Just add X2. This is the most beautiful thing. When you form X2, which is again chlorine and bromine, and this is important, no fluorine, no iodine, I'll tell you why. You get this product, and they mentioned something called anti-addition. What on earth is anti-addition here? We'll talk about that very quickly. Because of the way the reaction happens, okay, you get something called the brominium ion. It's going to get oxidized. It's going to get reduced, right? Rajanya, HI is a strong reducing agent. It's going to get reduced, I feel. HI may say iodine wants to get oxidized. It wants to do this. So it is a good reducing agent. But thanks for that prompt. Thanks for the prompt. Help me clear that out. So this is interesting. यहाँ पे a sort of a cyclic structure gets formed when this bond breaks, right? You have this, you have this, this. This is a brominium ion, I want to call it. Yeah. So this breaks heterolytically into Br plus and Br minus. Why? That's cool because it do. It just does. Okay. If you want to check out the mechanism of this, it's not relevant to you. But if you want to check it out, this is the reason behind why anti-addition happens. Because ये पूरा यहाँ पे तो यार एक तरफ यही बैठ रहा है, दूसरा ब्रोमीन अगर आएगा तो ऊपर से आएगा, ठीक है. Br अगर Br plus यहाँ से आएगा, Br minus will come from the top. That's why there is anti. Anti मतलब अलग अलग साइड पे. Syn मतलब same side, ठीक है. You don't need this, but a little bit extra information. Thought that will be interesting to you. If you want to know how this works, you can just go to the BYJU'S.com site. वहां से आप देख सकते हो इसका mechanism. Or you can also go to ChemLibertex, or you could also go to BYJU'S.com. So hey, that's like the most obvious site. You could also go to ChemLibertex, also go to Master Organic Chemistry. ठीक है? All right. This is interesting and important that you got to use this as a solvent. मैंने आपको बताया था कि जब एक रिएक्शन को पढ़ो तो उसको इनसाइड आउट पढ़ो, ठीक है. Maybe sometimes the reaction mechanism is complicated, ठीक है, but you got to always ask, what's the solvent here? Anyway, like solvent क्या होगा इसमें? किस चीज में what are you carrying out? Usually हम लोग जब फिजिकल केमिस्ट्री कर रहे थे we would not even talk about the solvent. We say हाँ पानी में हो रहा reaction. We don't even think about it, right? We started learning about different kind of solvents when we did solutions. अच्छा polar aprotic solvent, polar ये सब ये होता है. अच्छा like dissolve like. अगर तुम benzene और toluene को ऐड करोगे तो it's a chill, कुछ नहीं होता है. It's an ideal mixture. If you add this and this कुछ होता है. So you understood कि by changing the kind of solvent, the polarity बदलती थी और भी चीजें बदलती थी. उसका boiling point बदलता था. ये सब होता था. But here, solvent makes a lot of difference. If you put water as a solvent, सीधे alcohol बन जाएगा. You are not going to get all of this. ये सब होगा ही नहीं. So this is important. Okay, you use this sort of a solvent, CH2Cl2, and not water. We will look at this later in alcohols, ethers. कि अगर तुम पानी डालोगे, सब जगह the easiest thing to do is just put water. There is a high likelihood of forming alcohol. And again, please don't quote me on this. I'm just saying this. ठीक है? ये मैं इसलिए बोल रहा हूँ क्योंकि कभी-कभी students इसको नहीं समझते हैं कि क्यों यहाँ पे पानी नहीं डाल सकते हैं as a solvent. Maybe an assertion reason thing comes into a picture. Simple thing, right? What's a solvent here? This is solvent. This is solvent. Cool. Okay. All right. Oh, by the way, all this is for ये मैंने आपको दिखाया with symmetrical alkene. What if it's asymmetrical? अगर asymmetrical है तो वही होगा. ठीक है? It's the whole idea of Markovnikov addition all over again. वैभव क्या समझ में नहीं आ रहा है? You have just landed up here. What is it that you're not understanding? Can you go into detail? If you're doing time pass, then ठीक है नहीं हो जाए कर ले यार. If you really don't understand something, explicitly मुझे बताओ क्या नहीं समझ में आ रहा है. I'll try and help you. ठीक है, cool. This is an example of an electrophilic addition reaction. What is this electrophilic addition? Well, something that has a plus charge. Electrophilic, जिसको electrons पसंद है. Electrons कहाँ पे है? Electrons इस pi bond में है. The pi bond has electrons. What is electrophile? Something that has a plus charge. In this case, plus charge कहाँ से आया? इधर से आया. ठीक है? I told you there's a heterolytic cleavage that's happening over here, and this is the intermediate that is formed. Okay, which is not in the syllabus, but anyway, extra information for you. Have fun with it. ठीक है? This is the halonium ion जिसकी हम लोग बात कर रहे थे, वो यहाँ पे फॉर्म होता है. ठीक है? वैभव, any inputs और बस ऐसे ही? The next idea of preparation of alkyl halides is कि मेरे पास already एक halogen बना हुआ है, and I can play around with it. Make another halogen. Why would you do that? Let's see. Let's see. There are two different name reactions here, and this is what NTA loves. Yeah, they like this. They like this something. They'll give you a match the column. They'll say identify. ये है Finkelstein reaction. ये है Swarts. ये है Sandmeyer. क्यों? I don't know why that is going to be useful to you as a doctor or engineer, but NCERT इसको पूछता है, NTA पूछता है, तो I'm telling you this is important. Yeah, these name reactions are important. Finkelstein and Swarts. What is Finkelstein reaction? Well, you take Rx and you make it react with NaI, and this is how you form an iodide. Okay, मैं बताया था ना कि आपको bromo alkane, not iodide, let's see, iodoalkane, let's call it that. Okay, why are we doing this? There are two things here. Again, you add with Ni, Rx. Rx मतलब X क्या हो सकता है? ClPr. Not fluorine again. We'll talk about fluorine later. Fluorine is the odd person out of all of these things. There's a scientist that got like a specific name reaction after him because they figure out कि fluorine को कैसे react करते हैं. So we're adding NaI and acetone. That's interesting. See, NaI की polarity is not that high, and acetone again is an apolar aprotic solvent. ये शब्द आप लोग जो है समझने की कोशिश करो. एपोलर मतलब कि नॉन पोलर. दिस इज एसीटोन, इट्स नॉट पोलर. ठीक है? ओके. एप्रोटिक मतलब एक्चुअली एप्रोटिक तो नहीं है, प्रोटिक तो है, सॉरी. इट हैज हाइड्रोजन, सो इट्स नॉट एप्रोटिक, बट इट्स नॉट. Okay, let's not do aprotic. Let's just call it apolar right now. Aprotic मतलब CH2, carbon disulfide. There's no protons there, right? यहाँ पे है H, although they're not very acidic, but ठीक है. Let's stay clear of the aprotic वाला thing. For example, aprotic is this. ठीक है? Protic मतलब यहाँ पे H है. ठीक है? Okay. This is why, because it's apolar, NaI dissolves in acetone. Why? Because polarity of NaI is low. What? What are you talking about? Polarity is low? Yeah, let's look at it. Let's go and look at it. How are we going to look at it? Let's go to my fun side. Let's go to electronegativity. electronegativity, yeah. Iodine की electronegativity देखो, it's 2.66, yeah, and in fact 2.66 is around that of carbon. Okay, so sodium, which is 0.93, right next to my head here, sodium की देखो value है 0.93 electronegativity, and iodine is all the way over here at 2.66, which is very, very well low as compared to fluorine, which is 4, chlorine, which is 3.1, bromine, which is still 3, and this is 2.66. Okay. The reason why I'm spending time on this and making you see this is, look at it. ये sulfur जितना इसकी electronegativity is somewhere close to that, yeah. 2.58 iodine. I think this is closest to sulfur or carbon. Sodium does form sulfide, sure. Sodium iodide is not that polar. The reason I'm showing you all this is to say, yeah, it's not as polar as NaCl or NaBr. And that property is what we're going to use to prepare this compound. It's pretty awesome, right? So what are we doing here? So NaI, it dissolves in acetone because it's low polar, okay, dissolves. But जैसे ये and obviously this is reactive, right? So exchange हुआ था, ठीक है, cool. And this gets formed. This forms a precipitate because these are not soluble in acetone because they are quite polar. See, pretty cool, right? This is the awesome part about this. So, यहाँ पे NaCl, NaBr are polar, so they will not dissolve in acetone. They will come out as precipitate, and you're happy. This is a good way to make this whole thing. जहाँ पे Ri is formed, iodoalkane is formed. This is called the Finkelstein reaction. I spend a lot of time on these individual reactions so that you understand everything about them. That's important that we do that. Because once you do that, बाकी आगे की चीजें तो आप लोग खुद कर लोगे, questions कर लोगे, everything कर लोगे, you'll mug vomit, वो सब कर लोगे. But understand everything about this. Okay, क्यों? Why this? Why this? Why not that? सब चीज समझो. ठीक है, let's move on. Aryabhatta is a funny guy. The original Aryabhatta, no, but this guy, this Aryabhatta is a funny guy. All right. And because there is a precipitation happening, this automatically pushes the reaction in the forward direction. You know how that works, right? What does that mean? Dekho, there's an equilibrium over here. And because precipitate is being formed, let me put this here, which means it looks like the product is going out of the solution. If product is going out of the solution, more forward, reaction goes more from the forward direction. So that's a beautiful way to figure this out. That's why we gotta remember his name, Finkelstein. Finkelstein. All right. Next one is Swarts reaction. What did he do? He figured out how to form fluoride, the elusive fluoride. Till now we've been saying कि कुछ भी बना लो, fluoride नहीं बनेगा, explosive है, ये है, बहुत drama हो रहा है इसका. This guy figured out to make fluoride. Okay. So these are the different kind of reagents that could be used. Okay. The best ones actually, in fact, is SbF5. Now, what is Sb or SbCl5? Reagents that I use. What is Sb? Antimony. You want to know what Sb is? Here you go. Sb kahe ko? Why Sb? Look at it. Sb is in the same group as arsenic and phosphorus, but the electronegativity Sb is lower, 2.05. Remember, I've left this table on the electronegativity wala chart, okay? Because that matters a lot. I'm going to go back to that. I won't talk about too much detail as to, in this, but just for extra information, this is a really good reagent used. You'll see that all of their electronegativities are not that high. Between fluorine and this, fluorine is very high, but silver, let's go back. Ek bar, just once. Silver, cobalt, NCERT mein likha tha. Let's look at that one more time. Silver is 1.93. See, it's very close to that of antimony. Silver is 1.93. This is 2.05. Dusra kaun sa tha? Cobalt. Cobalt is 1.88. Again, pretty close. You see that? That's why these solvents are used. Not solvents. These reagents are used. Okay. These are reaction conditions, not solvents. These are reagents. Okay. So, to form RF, which is fluoroalkane, from bromoalkane or chloroalkane, this is a general reaction. And again, you can read up more about it if BYJU'S.com/Swarts reaction literally from there. Yeah. All right. This is it. So you add AgF. This comes out as a precipitate. This is in solution. Okay. You can also, this is also used to produce freons. Bit of extra information. All right. Let's go to some questions. बहुत theory हो गई. एक दो सवाल कर लेते हैं. Yeah. Swarts, my friend, Rex S. Unless you're in like 6th grade and you want to talk about that. Is when oxide reduce. Okay. Okay. Forward. Yes, Mehak. Absolutely. Antimony. Yeah. Cool. How many isomers, including stereoisomers? Acha. Now we're talking about all isomers. Oh, this is going to be fun. This, I think, is more of a JEE main kind of a question. Maybe to an extent, not really JEE advanced, but sure, JEE main type ka sawal hai. Although I know I'm on the main channel. But remember, I'm doing this content for both JEE and NEET, so anybody can watch it. If you find this to be a little bit difficult as a NEET student, don't worry about it, right? ऐसा सवाल आने की कोई chance नहीं है in NEET. आ गया तो it'll come as a something with options, obviously not without it. I'm just asking number of isomers, but we'll still do this. Okay, so this is including two things. One is stereoisomers. You'll be able to do it, even as a NEET student, you'll be able to do it because you figured out how to find stereoisomers, chiral centers, and all that. अब उसके साथ बस structural isomers भी बता दो, monochlorination of these things. Okay, and it's not a very complicated compound. Let's quickly draw its structure. है ना? Monochlorination of this compound. यहाँ पे H आ गया, यहाँ पे ये आ गया. Let's not draw this H. Just confuse things unnecessarily. 1, 2, 1, 2. Okay. So this is 1, 2, 3, 4, 5, 6, 7. Let's do that. 1, 2, 3, 4. कुछ तो गड़बड़ किया मैंने. What? What did I draw? I think I drew one too many things. रुको मैं इसको फिर से बनाता हूँ. What? 1, 2, 3. This is the methyl group. 1, 2, 3. Oh, no. It's like this. 1, 2, and third. So this is the methyl group. And even if I draw it like this, ठीक है, कर लेते हैं, draw, कोई tension नहीं है. 1, 2, yeah. This is the compound. All right. This, the bat-like thing, this is the compound. Okay. Monochlorination. अगर मैं क्लोरो यहाँ पे लगाऊं, that could be one compound. Okay. अगर मैं क्लोरो इसको यहीं पे ऐसे रहने दो, मिथाइल को यहाँ पे रहने दो, यहाँ पे लगाऊं, that can be another compound. If I make this, say, chloro over here, that is another compound. Are any of these do any of these have chiral centers? देखते हैं. 1, 2, 3. हाँ, ये वाला तो chiral लग रहा है भाई. See, this one looks like a chiral center. I'm going to mark green from what I see. आप लोग भी करते रहो, आप लोग कोशिश करो. This looks like a chiral center to me. This is not chiral. This is achiral. ये वाला achiral है. Because same, right? Same groups on both sides. All right, sweet. Okay. What about this right here? इसमें chiral center है क्या? मुझे लग रहा है ये वाला chiral center होगा. आपको क्या लगता है? I think so. I think this is going to be chiral. Right? You got a hydrogen over here, of course. यहाँ पे भी hydrogen है. There are different groups, right? There is an ethyl group over here. There is some other group over here. ठीक है, cool, sweet. I think this is chiral as well. इसको थोड़ा cleanly बनाया जाए. This is chiral as well. Okay. What about other substances? 2 isomers, 2 chiral centers. Okay, देखेंगे. अगर ये 2 chiral center हो गए, अगर एक ये हो गया, तो इसके हिसाब से I've got 5 already. Do we have more? Do we have more? Let us see. और क्या हो सकता है? Redrawing the structure एक बार फिर से. Okay, this is the original compound. अब क्या करें? Iron. See, this is the mess up. This is not it. This is the compound. यहाँ chlorine लगाना था. Okay, great. Now what do we do? I added chlorine at the end, in the middle. This is middle में, end में और बीच वाले carbon पे. But 1, 2, 3, 4, 5. This is the wrong compound. This needs to end over here. This is the actual compound. ठीक है. 5 ही देना. 1, 2, 3, 5. 1, 2, 3, 5. Okay, cool. अब added the first carbon, second carbon, third carbon. और कहाँ ऐड कर सकता हूँ? Well, यहाँ पे भी ऐड कर सकता हूँ मैं. इस हाइड्रोजन को हटा के यहाँ पे भी ऐड कर सकता हूँ. But this is also achiral, right? This is also achiral. Looks like it is achiral to me. ठीक है? But interestingly, और कुछ बताए chiral? No, because it's the same compound. What do you think? Joel, Carros acid. Sure, I mean, you can look it up. Fan Club G, go to the bento link, check it out. Let's focus on what we're doing here right now. Ask questions there, please. Any other kind of structure जो आपको दिख रहा है? Any other kind of structures? So I've got 4, 5, 6. I've got answer is 6. Is that the answer? What do you think? Joel, Rajanya, Mehak, what do you think? Are there any other kind of structure? I've drawn 4 structures. Is there a 5th structure that I can draw? सोचने दो. क्लोरीन यहाँ लगा दिया तो ये वाला कायरल हो गया, ठीक है. फर्स्ट में, सेकंड में लगाया कायरल हुआ, तीसरे में लगाया कायरल हुआ, चौथे में मतलब सच में तब कायरल नहीं हुआ. दिस वन इज कायरल. इंटरेस्टिंग. एनीथिंग एल्स? 2 so far? Okay. Let's see. Is there any other way? So yeah, let's draw them together. This is something we accounted for. This is also something we accounted for. This is also something we accounted for. Oh, what is this? दो chiral center. Let's go back and quickly see. If we add here, यहाँ पे chlorine add किया, right? Then you get 2 chiral centers in the same compound. See that? Look at that carefully. You don't see any more? Yeah, Joel. You are absolutely right. There are no more different compounds, but we missed out one chiral center over here. है ना? देखा आपने? You see that, Joel and Rajan as well? MSRTC. What is MSRTC now? Is it like KSRTC, like the bus thing? Are you a fan of a bus? Cool, man. You do you. Anyway, Caros acids. Guys, you guys are funny. Good try to throw my train of thought off from what I was thinking. Anyway, so there are two chiral centers here because यहाँ पे देखो there's a methyl group, there's an ethyl group, and here there's some other group. So two chiral centers. Because of that, this gets 2 power 2, which is 4, and this is plus 2. So that's 6, and then 7, and then 8. So hence the answer should be 8. Pretty awesome question, don't you think? Lovely question. Yeah, this is the thing to be careful about in this question. And in fact, देखा जाए तो ऐसा सवाल JEE main में नहीं आएगा. JEE main also आजकल बहुत straightforward हो गया है. It's become a high scoring test. It's not going to come in JEE main either. Perhaps in NEST or IIT or something like that, right? If this kind of question comes. Yeah. Isn't that same as the left side? Rajan, yeah, what do you mean? यहाँ पे अलग अलग है ना. देखो यहाँ पे methyl है. This is ethyl. And this is a different group. So you got chiral center 1 and chiral center 2. So you've got two chiral centers here, 2 power 2, which is 4 enantiomers. Well, 4 optically active compounds. They're not 4 enantiomers, that makes sense. 2 enantiomers and 2 pairs of enantiomers. 4 optically active compounds. Right? And then plus 2 more. 2 optically active. And then 2 achiral molecules. Right? So that's 4 plus 2 plus 1 plus 1, which makes a total of 8. We good? ठीक है, आगे बढ़ा जाए. This is a fun question, right? What is the how do you synthesize alkyl fluoride? या same ही होगा. अब left right now left will be the same. Rajan, yeah, right या left में same ही होगा because it's a symmetrical thing here. Yeah, so if you put Cl over here or over here, it's the same. Similarly, if you put Cl over here or over here, it's the same. इसलिए मैंने बाकी और draw नहीं किया. That's right, you're right. How do you find out? Now, so this is a very relevant question. This is something that is highly likely to come in something like JEE or NEET. The current state of JEE and NEET, right? My goal is to prepare you for the current state of JEE and NEET, not 10 साल 20 साल पहले क्या हुआ था. Alkylate fluoride कैसा होता है? किसको याद है? देखो Finkelstein जिसमें F लिखा हुआ है, no fluorine. This is how I mug it. If you want to mug things, you want to get to ground. What's your trick of mugging this? जहाँ पे alkyl fluoride बनाना है और नाम F है, तो there is no fluoride being formed. Finkelstein is for not for fluoride, it's from iodide. Swarts is the answer for this. ठीक है, let's go आगे बढ़ते हैं. ठीक है, चलो. हाँ. Okay, let's do a little bit more theory, and then we'll get back to some questions if you still have some more time. Yes, Finkel, yes, absolutely, Mahek Rajan, yeah, बिल्कुल सही. Yes, Joel, good job. Now let's go on and see how aryl halides are formed. Aryl मतलब phenyl ring के साथ. Yeah. Halogenation of arenes or diazonium salt. This is interesting. इसी को हम लोग बोलेंगे Sandmeyer reaction. Spoiler alert, right? Halogenation. कैसे करेंगे halogenation? Okay. Seems like it's the easy thing to do. Well, you've got a benzene ring and something to it. Whatever. What do we add? कुछ add करेंगे उसमें. क्या add करेंगे? Can we add HX? Can we add X2? What do we add to it? Think about it. Remember, मैंने आपको बोला था कि every organic reaction is an acid-base reaction, and benzene is electron rich. मतलब if I get E plus to attack it, मजा आएगा इसको. It'll be good. How do I get E plus to attack it? Say I've got E plus is electrophile. Say I've got X2. How do I ensure that it breaks as X plus and X minus? This is heterolytic cleavage. How do we do that? Well, we use something called as a Lewis acid. What does a Lewis acid do? Lewis acid will cause this cleavage to happen. What is a Lewis acid? Something that really wants electrons. Okay. If it wants electrons, दे देगा. This is a Lewis acid. Okay. And अगर ये behave कर रहा है Lewis acid की तरह, then this is going to be your Lewis base. Look, acid और base साथ में react करते हैं. अलग-अलग नहीं exist करते. So there is something behaving as a Lewis acid. Something else must behave as a Lewis base that reacts with it. Okay. Hence there is heterolytic cleavage happening. ठीक है? So this is called the electrophilic substitution reaction. जो आप थोड़ा बहुत 11th grade में भी पढ़ चुके हो, GOC hydrocarbon में भी उसको I'm sure you've read it. Okay. And this is a general reaction for any aromatic compound. Has a lot of electrons, so you give it something that's E plus, it'll be happy. It'll happily given H plus. जाओ जी लो अपनी जिंदगी टाइप. So use FaCl3 or AlCl3, and what happens practically if you want to see this, plus Cl Cl, and this bond breaks. Arrows कहाँ से draw करते हैं? You start the arrow from where the electrons are from the bond and you end it where it needs to go. Okay, so this gives you Cl minus plus Cl plus. Okay, then these guys like, hey, aluminium wants this, so it becomes AlCl4 minus plus Cl plus. But hold on, AlCl4 minus or FeCl3, you don't see that. You're saying that there's a catalyst. It gets regenerated at the end. ठीक है? ये AlCl4 minus will then react with H plus to give me again AlCl3 plus HCl. Everybody is happy. Hence you have that on the other side. ठीक है? Cool. So AlCl3 just acted as a catalyst. The Lewis acid, it did not get consumed. It helped things out. जो Cl2 था, Cl2 itself went into that reaction there and also HCl. Awesome, right? Pretty beautiful. If you want to look at the, this is just a benzene ring. Yeah, this is the reaction mechanism. Electrophilic substitution reaction. Yeah, exactly. This B minus here is basically AlCl4 minus. Okay, that is B minus. And Cl plus is basically the heterolytic cleavage that goes and attacks it directly. I have given you the reaction mechanism in detail. Now, this works for, again, chlorine and bromine, not so much for fluorine and iodine. Now, what do we do for fluorine and iodine? कुछ और करेंगे. कुछ और करेंगे. Fluorination, very reactive, and I2 is too slow. Hence, diazonium salts. Diazo, ये क्या चीज है? We'll see. So you take a primary aromatic amine, and again, you will study this zabardasti फिर से in the amines chapter. So as I told you, 12th organic is very linked. So साथ में करना सब चीज को मजा आएगा. Now, so you have read this here, diazotization. I would suggest and recommend this. After this session gets done, थोड़ा सा amines में भी जाकर देख लो ये diazotization क्या भला है. थोड़ा पढ़ लो, वहां पे भी सेम ही चीज है. ठीक है? So you add HNO2, nitrous acid, not nitric, HNO2 at low temperature, 0 degrees to 5 degrees Celsius, to give diazo salts. ठीक है? What is a diazo salt? देख रहे हैं. Now, why are we adding NaNO2 and HCl? I said यहाँ पे nitrous acid. Same thing. This is in situ. मतलब अंदर HNO2 बन जाता है. That then gives you the NO plus ion. That then becomes this. ठीक है? Nitrosonium ion is what it's called. Again, if you want to look at the reaction mechanism in detail, go to BYJU'S.com, Sandmeyer reaction, you will see the reaction mechanism. It's not necessary for you, but I would still suggest it's a good thing to do, good practice to do. मैंने आपको थोड़ा hint दे दिया है कैसे होता है. The moment you've got NO plus, मतलब, hey, great, this is, this will attract some sort of a minus species. What is a minus species? Chloro, right? But this is not it, right? I'm not saying कि यही से आपको मिल गया X. That is not what is happening here. Here we are preparing the precursor to that. We are preparing the diazonium salt. I have to react something else here, like say, let's say something that has X to give me this compound. Okay? This is not production of this thing. This is the preparation of the diazonium salt itself. Okay? So I take aniline, 0 to 5 degrees Celsius, NaN2HCl, and I get this N2Cl बन जाता है, N2 plus Cl. This is the diazonium salt. Why is this a salt? Because plus and minus, they are clear charge separation. No more delta plus delta minus. Yeah, there's a clear charge separation. Benzene diazonium chloride. Awesome. After that I told you something as X. उसको अगर आप react करो cuprous chloride, cuprous मतलब CuCl, CuCl2 would be cupric, है ना? ये है cuprous. और bromide मतलब CuBr, तो बन जाएगा aryl chloride और bromide. This is the Sandmeyer reaction. Cool. And साथ में nitrogen निकल जाता है. Now, the kind of question I've seen in JEE and NEET is not so much about this, but about this. Oxidation state of nitrogen, some random thing like that. Or I'll say ki, which of these products is there in the Sandmeyer reaction? NO2, NO3 minus, N2, none of these. Something like that. I'm like, wait, what? You guys have bugged. Everybody's bugged ki Sandmeyer reaction मतलब बन जाता है ये chloro या bromo product. But a lot of people forget that N2 and don't, right? It's simple. In all diazotization reactions, you get N2Cl, and then after that, nitrogen gas निकल जाता है. ठीक है? तो इसमें मैं बोला कि amines में भी थोड़ा जाके पढ़ लेना इसके बाद, it'll help you out a lot. हाउ डू वी फॉर्म आयोडोबेंजीन? हमने फिगर आउट कर लिया कि क्लोरोब्रोमो कैसे बनाते हैं, अब आयोडीन और फ्लोरीन का देखना है। आयोडोबेंजीन के लिए you don't need something like cuprous or something fancy. Just use Ki. Okay, Ki is easily available, cheaper, much cheaper than all those fancy copper salts and all of that. Just do this and do this. Yeah. This is not Sandmeyer reaction. Let me write that specifically. Sandmeyer was only for chlorine and bromine. I know semantics. Sandmeyer ने इतना काम किया, उसको इतना credit देंगे. Sandmeyer did not do this, so let's not give credit for this. Okay. Cool. So that was basically the session. That was all we had for you today. Fluoro, I have to tell you how to form this. ये कैसे बना जाए? अगली बार करेंगे, ठीक है? So that was all I had for you today. If you want more practice, more questions, you know the drill, right? मैं ऐप से practice session करूंगा आप साथ में. I have around 6 sessions planned for you for haloalkanes and haloarenes. After that, we'll do a practice session, separate one for JEE, separate one for NEET. ठीक है? The theory session is going to be the same because the theory is the same. Theory में कोई फर्क नहीं है, ठीक है? अगर आपको थोड़ा एक्स्ट्रा पढ़ना है, you know where to go. Go check out the reaction mechanism of all of these things that I'm talking about over here. So to summarize everything that we've done today, पहले मैंने I started off with the whole idea of how do you prepare haloalkanes from alkanes and alkenes. Alkanes it was simple, free radical mechanism, and we have the order of stuff. We don't do this. Don't do this because it's explosive. Yeah, and this is again reactivity of H in terms of radical halogenation. Yeah, not carbocation and all of that. Monoalkanes, dialkanes banane hai from alkyl halides. From alkenes. You add HX, it's chill. Markovnikov rule follow karta hai if it's asymmetrical. And X2 if you add, it forms a brominium ion, and you need to use CH2Cl2 as a solvent. Okay, not water. And this is called an anti-addition extra information. That's it. And vicinal dihalides get formed. What is vicinal? Alag. Gem was same. We learned that in the last session as well. Yeah, and this is an example of an electrophilic substitution reaction. Brominium ion gets from halonium brominium, in this case bromine, so halo gets replaced with that. Finkelstein reaction, first name reaction in this chapter so far. You add NaI because less polar and soluble, likha hai. Soluble likha hai. Okay, and these form precipitate, pushes the reaction forward direction, which is awesome. Swarts reaction, finally a way to form fluoride. Yeah, these are the reagents to use. Another one is HPCl5 or SPF5 can be used here. And aryl ka we've just done this. Yeah, halogenation kaise karna hai? Use a Lewis acid, FeCl3 or AlCl3. I showed you the reaction mechanism of that as well. And electrophilic substitution reactions mein you focus on Cl2 and Br2, not really these because this is too reactive and this is really slow. To form iodine, just add Ki to a diazonium salt. This is how you form a diazo salt. This is called a Sandmeyer reaction if you add CuCl and CuBr. If you use Ki, this is not Sandmeyer. I know we just did this, just making sure. All right, have fun. And let's quickly look at NCERT. हमने सब कुछ cover किया है, but I'm just still going to mention it again over here. Yeah, just go over it very quickly. Yeah, alkanes by free radical halogenation. We've done this from general alkenes. Although they don't go into so much detail, but they tell you that it forms Markovnikov product, which is major, right? They tell you this. Addition of halogen. They've used CCl4. I also said CH2Cl2 could be used. This is, and you get a vicinal anti this thing, and this is where the halonium ion gets formed. Some extra stuff over and above NCERT just to tell you how things work. Halogen exchange reactions, Finkelstein reaction, the first name reaction was there over here. The solvent here is acetone. For extra information, also very important. This is a precipitate. So same चीज जो मैंने आपको पहले बताई थी. Swarts reaction. देखो एक छोटी सी लाइन लिखी. You may miss it. That's why I have it on one big slide here because it's tested. Haloarene के लिए Fe dark, etc. or Sandmeyer. You do this. You could also use AlCl3, yeah, Lewis acid. And yeah, that was it for today. Use Ki. You don't have to use that. That's not Sandmeyer. फिर से लिख रहा हूँ यहाँ पे because students don't remember this for some reason. They forget. Sandmeyer के साथ में वो भी लिख देते हैं. Do these solved examples. Do all of these in-text questions. Please do this. Yeah. The first step is, I know you guys want to do 100 books, but सबसे पहले जो 5-10 सवाल NCERT में उसको तो कर लो. Do that. and then you do anything else. Do exemplar if you want to do more things. Do PYQs. उसके बाद कोई और extra book use करो यार. You don't need any paid resources. Everything free that's available is more than enough to get you through JEE main and NEET with really high scores, at least in chemistry. All right. Thank you everybody for your time. I'll see you around. Yeah. Bye. Have an awesome Thursday. I'm doing 8:30 p.m. पे periodic table के practice session on the JEE channel. आपके लिए NEET के लिए I will do on Saturday. You can come and attend both if you want. Extra practice रहेगी. Tata. Bye.